Hi guys, in this lecture we see about Carnot cycle. In last lecture we see about working of Carnot cycle and we saw three steps: isothermal expansion, adiabatic expansion and isothermal compression. Okay? Here first the cylinder is kept on source reject large amount of heat energy, therefore gas which is present, ideal gas which is present in the cylinder absorbs heat Q1 at a temperature, constant temperature T1 and expand isothermally and reaches to the state BP2 V2. And this can be shown here. It expand isothermally at a constant temperature T1 degree Kelvin and reaches to the state BP2 V2. This is shown by the isothermal AB, and in this the work done by the gas is given by, that is W1 equal to nRT1 log of P2 by P1. The bucket line happen. Okay? Then cylinder is kept on non-conducting support. Non-conducting support is a insulating stand, cannot absorb or reject heat energy. Therefore here gas expand adiabatically till temperature falls to T degree Kelvin and it reaches to the state C P3. This is shown by the adiabatic PC. And in this case, work done by the gas is given by, that is W2 equal to nR divided by 1 minus gamma T1 minus T2. Here, then the cylinder is placed on sink. We know that is sink has infinite heat absorbing capacity. Okay, therefore when cylinder is kept on sink absorbs heat from gas. Therefore, gas is compressed. Gas is compressed isothermally at a constant temperature T2 degree Kelvin. At a constant temperature T2 degree Kelvin and reaches to the state D P4. This is shown by the isothermal CD. In this case, work done on the gas is given by Q2 equal to WT equal to nRT2 log of P3 by P4, that is area CZ HD. एवढं आपण गेल्या पिरियडला इथपर्यंत बघितलंय. राहिलेला पार्ट काय आहे? फोर्थ स्टेप, that is here. Now the cylinder is kept on for a non-conducting support. Non-conducting support has zero heat capacity. Therefore here gas is compressed adiabatically. Gas is compressed adiabatically till temperature reaches to T1 degree Kelvin. T1 degree Kelvin, and it is shown by the adiabatic dA, and work done on the gas is given by W4 equal to nR divided by 1 minus gamma T1 minus T1, that is equal to area CZ HD. Here काय होतं या ठिकाणी, the cylinder is placed on insulating stand and adiabatic compression takes place until temperature reaches to T1 degree Kelvin. T2 पासून T1 पर्यंत temperature काय होतंय पोहोचतोय. That is, it is shown by the adiabatic dA, and work done on the gas is given by W4 equal to nR divided by 1 minus gamma T1 minus T2, that is equal to area CZ HD. Thus this cycle ABCDA is completed. Thus this cycle ABCDA पर्यंत आलो आपण. Thus the cycle ABCDA is completed, which is known as Carnot cycle. And this can be also defined as the reversible cycle of operation through which the working substance has been taken is called as Carnot cycle. Right? The reversible cycle of operation through which the working substance has been taken is called as Carnot cycle. Okay? हा ब्रॉड क्वेश्चन विचारला जातो त्याला जोडून इफिशियन्सी असते किंवा फक्त इफिशियन्सी ऑफ कॅर्नॉट्स इंजिन शॉर्ट नोट विचारली जाते, परंतु बऱ्याच वेळा 90% याच्यावरती ब्रॉड क्वेश्चन असतो कॅर्नॉट सायकल वरती, लक्षात ठेवायचं. नाउ वी सी द इफिशियन्सी ऑफ Carnot's engine. In this case here, there is work done by the gas is taken as positive. Work done by the gas is taken as positive and work done on the gas is taken as negative. पहिल्या दोन स्टेप्स, पहिली isothermal expansion, दुसरी adiabatic expansion. That are nothing but work done by the gas. आणि दुसऱ्या दोन स्टेप्स, that is आयसोथर्मल कॉम्प्रेशन आणि चौथी एरोमॅटिक कॉम्प्रेशन. यामध्ये जे वर्क डन आहे ते वर्क डन ऑन दी गॅस. मग काय आहे या ठिकाणी, तर वर्क डन बाय दी गॅस इज टेकन ॲज पॉझिटिव्ह अँड वर्क डन ऑन दी गॅस इज टेकन ॲज निगेटिव्ह. दॅट इज W इक्वल टू W1 आणि W2 हे काय आहे, पॉझिटिव्ह वर्क डन साईड. दॅट इज W1 प्लस W2 मायनस W3 मायनस W4. W3 and W4 with the work done on the gas, okay, that are negative. Therefore, total work done is given by W equal to W1 plus W2 minus W3 minus W4. That is equal to W1 ची व्हॅल्यू माहिती आहे, वरती आपण बघितलंय. W1 काय, nRT1 log of P2 by P1. Q1 equal to W1 equal to nRT1 log of P2 by P1. Therefore, W1 ची व्हॅल्यू पुट आउट करा, nRT1 log of P2 by P1 plus W2 काय आहे, adiabatic expansion आहे. Adiabatic expansion, work done during adiabatic process काय आहे, nR divided by 1 minus gamma into T1 minus T2. W2 ची व्हॅल्यू पुट आउट करा plus nR divided by 1 minus gamma T1 minus T2 minus W3, that is isothermal compression, isothermal process work done nR T1 nR T2 आहे, nR T2 आहे ते nR T2 log of P3 by P4 minus W4 काय आहे, adiabatic compression, that is adiabatic work done nR divided by 1 minus gamma T1 minus T2. That is equal to, कसं होतंय बघा आता, हा nRT1 log of P2 by P1 आणि हा nRT2 आहे, या ठिकाणी T2 आहे, nRT2 log of P3 by P4. ओके, हे डिफरंट आहे. आणि हे W2 आणि W4 कसे आहेत बघा, nR डिवाइडेड बाय 1 मायनस गामा T1 मायनस T2 आणि हा मायनस nR डिवाइडेड बाय 1 मायनस गामा T1 मायनस T2 plus minus cancel, remains only what, a W1 minus a W3, that is equal to W1 म्हणजेच काय आहे, Q1 आणि W3 म्हणजे काय आहे, Q2. That is W1 minus W3 equal to Q1 minus Q2, and this can be written as, that is equal to nR T1 log of P2 by P1 आणि हा nR T2 log of P3 by P4. Okay, but P2 by P1 equal to P3 by P4. हे कसं काढायचं, परफेक्ट गॅस इक्वेशन, दॅट इज PV equal to RT इक्वेशन माहित आहे तुम्हाला, PV equal to RT, किंवा this can be written as PV P1 P1 equal to P2 P2 equal to P3 P3 equal to P4 P4. P1 P1 equal to P2 P2 equal to P3 P3 equal to P4 P4. चार टर्म हो गए चार. This also can be written as, that is P1 by P2 equal to काय येणार, P1 by P2 equal to P2 by P1, that is equal to P3 by P4 equal to P4 by P3, that is P1 by P2 equal to P2 by P1, that is equal to P3 by P4 equal to P4 by P3. या इक्वेशन वरून आपण काय काढलं, P1 by P2, हा P2 इकडे गेला, हा P1 इकडे आला, P2 by P1, that is equal to काय करायचं आहे, P4 by P3, P4 बाय हा P3 इकडे आला, P4 हा P3 खाली आला आणि हा P4 इकडे जाईल, P3 by P4, P3 by P4 equal to P4 by P3. जे आपल्याला काय पाहिजे होतं, P2 by P1 equal to P3 by P4, P2 by P1 equal to P3 by P4. इथं P2 by P1 आहे, P3 by P4 आहे. Therefore, this W can be written as W equal to nRT1 log of P2 by P1. P3 by P4 च्या ऐवजी P2 by P1 घ्या minus nRT2 log of P2 by P1. Therefore, W equal to nR log of P2 by P1. इथं P2 by P1, P2 by P1 log nR कॉमन काढला, nR log of P2 by P1 कॉमन काढला, इंटू ब्रॅकेट काय राहील, या ठिकाणचा T1 आणि या ठिकाणचा T2, T1 minus T2, which is suppose equation. This is suppose work output. This is suppose work output, that is total work done, work output, which is given by nR log of P2 by P1, T1 minus T2, which is suppose equation 3. And work input is given by, that is our first equation, W1 equal to Q1 equal to nRT1 log of P2 by P1. This is nothing but work input and this is nothing but work output. Then efficiency of Carnot's heat engine is given by eta equal to work done or work output divided by work input. Work done or work output divided by work input. Work output किती आलं आपलं, nR log of P2 by P1 into bracket T1 minus T2, first equation. Work output किंवा work done काय आहे, nR log of P2 by P1 into T1 minus T2 आणि divided by work input किती आहे, nRT1 log of P2 by P1. आता हा आउटपुट चं इक्वेशन काय आलंय आपल्याला, आउटपुटचं इथं W1 minus W3 किंवा Q1 minus Q2. ओके, that is equal to Q1 minus Q2 म्हणजे हा वर्क आउटपुट डिवाइडेड बाय हा वर्क इनपुट काय आहे, Q1 आहे. पहिले इक्वेशन बघितलं, Q1 minus Q2 by Q1 किंवा that is equal to या इक्वेशन वरून काय आलं, हा nR log of P2 by P1, हा nR log of P2 by P1 कॅन्सल आहे. जर हा वरती काय राहिलं, T1 minus T2 divided by हा T1, that is equal to T1 minus T2 by T1. Okay, efficiency eta equal to Q1 minus Q2 by Q1, that is equal to T1 minus T2 by T1. Q1 ने याला डिवाइड केलं तर असं होईल, 1 by Q1 1 आला minus Q2 by Q1. Therefore, eta equal to 1 minus Q2 by Q1, that is equal to T1 ने डिवाइड केलं याला 1 आला T1 by T1 minus T2 by T1, 1 minus T2 by T1. Efficiency का formula काय आला, eta equal to 1 minus Q2 by Q1, that is equal to 1 minus T2 by T1, which is nothing but efficiency of Carnot's heat engine. याच्यावरती एक्झाम्पल येऊ शकतं किंवा शॉर्ट नोटला विचारतात आणि जवळजवळ 90% याच्यावरती Carnot सायकल वरती काय असतो, ब्रॉड क्वेश्चन असतो. Then we see Carnot's theorem. Carnot's theorem एकच theorem आहे, हा कधी विचारला जात नाही, परंतु लक्षात ठेवा मल्टिपल चॉइसला वगैरे विचारलं तर Carnot's theorem काय आहे, all the reversible engines working between same temperature limits, all the reversible engines working between the same temperature limits have the same efficiency and no engine can be more efficient than a Carnot's reversible engine working between the same two temperatures. Right? All the reversible engines working between the same temperature limit have the same efficiency and no engine can be more efficient than a Carnot's reversible engine working between the same two temperatures. This is nothing but Carnot's theorem. Okay, या ठिकाणी आपण थांबू.